not going to shoot that down. What are we going to shoot?
Oh, okay. All right. Okay, welcome everybody to our weekly weather discussion. Come on in. We do this every Friday, as many of you know, from 12:15 to about 1 o'clock. Today I'll do the current weather, and then Patrick Beatty's going to do the forecast. And so we're going to start to rotate people through, which is great. Yeah, and he's got a lot of fans. That's the acclaim is worthy. It's well deserved. So you'll see that in action today if you never have before. We're going to start with just a sort of an overview. I did not. What I wanted to do, and I just start out with an apology. I wanted to have the month of January 850 cold pool tabulated for this whole year and then compare it against the long-term average, because in many other measures, January 2023 was unusually warm in the Northern Hemisphere, a lot of different places and so on. I suspect it's in the top 10. I wouldn't suspect it's in the top 3 for average for January against the long-term average. But I may be wrong, and I'll bring that next week, even if I'm not giving the discussion. It looks as though Isaac and Kalen may give the discussion next week, which is great. Just about guarantees a major snow event in the offing for them. So that's one thing. So I want to give you an overview of the current weather. Most of what's really, I think, exciting today is going to be the immediate future weather, and I might just go a little bit into the future for one thing that Patrick and others have alerted me to, and I'll begin by mentioning it here on the satellite picture. So here's the pseudo blue-green color visible satellite image over the last 6 hours from today. So a couple of really interesting features on the map. Number one, this is a major cloud feature that doesn't seem to have a really obvious connection to a cyclone, I think because the flow is so strongly stretched. Maybe the cyclone's over maritime Canada. But we'll see in the radar that for a while this morning there was pretty heavy precipitation along the coast, and now you can see it's all pretty cleared out. So that's one interesting feature. Another one is, look at this, stratocumulus coming off the coast of Maine and also off Long Island. Extremely cold air, and this isn't even the coldest. It's going to get worse for them. But this is really beautiful stratocumulus. If you were sitting here at Halifax looking southeast, southwestward, you'd probably just see these streams of low-level stratocumulus out your window. Some of it undoubtedly is snowing by the time it gets 10, 20, 50 miles offshore and so on. So really pretty cool. For some reason, most of coastal Massachusetts is immune to any of this. It probably is the interspersed nature of the topography given the wind direction, which is obviously because the lines of the individual cloud streets are indicating the wind direction that's organizing those bands. It's pretty much northwest. And so you go from southern New Hampshire over Massachusetts Bay, then over Cape Cod, over the islands, and it might be enough friction to just keep it a little more difficult for convergence to really set in. Because immediately southeast of the islands, or southwest of the islands, off of the Narragansett Bay and then along Long Island, where you don't have so much variation, you start to pick it up again, and you certainly do off the coast of Maine. You can also see in this image snow over northern New England, just not any yet in my hometown, which is right there. And it's been the most boring winter. My poor father now, he's going to turn 89. He loves the winter. And so he's just dying for something interesting to happen, and I think all he's going to get is minus 12 tonight. So, and I wish I could do something about it, but I can't. One of the cool things that you can see over Ontario and Quebec is that there's very light, it looks like high, thin clouds. We're going to see when we go to the infrared satellite image that this is bright white. So this is just extraordinarily cold air, and it shows up even in the infrared as a result of all of that. And all of the lakes in Ontario are frozen now with snow coming, so it's brutal. Recent snow over parts of Texas, just to the northwest, I guess, of Dallas. Some light snow over southern Missouri, over the Ozarks, and then over the Mississippi Valley in Arkansas and Cape Girardeau area. So that's kind of interesting. And one can't see too much through some of the, I guess this is light clouds, it's going over a brand new snow cover over the Central Plains states. And then when you get up into the pine forests of Wisconsin and the Upper Peninsula, you see it looks like, well, there's no snow anymore. Same in Ontario. Now, don't be fooled. These are just agricultural regions, so there's no trees. So you've got all these trees sticking through the snow, and they're absorbing solar radiation and radiating infrared, and And you get these big bowls around all the tree stumps and tree trunks. Pretty interesting up there. Widespread clearing over the southern United States, all the way to the Four Corners area. And then kind of a confused look, we'll see with a little more detail in a minute, confused pattern in the atmospheric circulation over the Pacific Basin. Lots of small-scale swirlies. It looks like there's no organization at all. And that's, I'd say that's relatively uncommon during the cold season, but it does happen episodically, and we're in one of those right now. Okay, Pete, if we could go to the infrared, that would be kind of cool to see too. So here, I thought we were going to go to black and white, but this is just as good. This green indicates those temperatures, if it's the high clouds or the surface, are as cold as these proto-convective clouds off the coast of the Carolinas. So this is really cold air that's sitting over the eastern part of Canada. And I'll remind you that I think our first discussion was the first Friday of the term, which was that only a week ago? I guess it was only a week ago. And we were thinking, wow, February 3rd could be brutal here. And then on the Tuesday or Wednesday before the term started, remember that? And then suddenly something changed in the forecast and it looked obvious that the coldest air was going to slide to our north and east and kind of affect maritime Canada and New England. And boy, that was locked in about 7 days ago, and that's been right on target. So what looked like, as the term began, this Friday being the coldest, absolutely the coldest day of the year, and well below normal, ended up probably still being the coldest day of the year, but not in the -20 range like it was feared about 10 days ago. So we were -8 this morning at the airport. I think that beats what we were on Tuesday. So that is the coldest morning of the year. But I didn't look up the other one. I looked up the temperature this morning. So one of those 2 days, the coldest day of the year. And this is right at the peak for cold, on average, around the whole hemisphere in the wintertime. You don't get colder, usually, on average, you certainly don't get colder than the last day of January, first day or 2 of February. That's about as bad as it gets. And this year, at least in our locale, maybe is actually testifying to that broad average in the numbers that we're seeing now. Okay, so here's the cloud streak that we saw on the visible. One gets the impression that some of these deeper clouds probably have some precipitation coming out of them. Neither of the two portrayals we've yet seen can tell us that for sure. We'll look at the radar in a minute. And here's a broad circulation north of the St. Lawrence River Valley in Newfoundland, way up to the north. And that might be the circulation that's tying all of this stuff together. There's a broad anticyclone sitting over the central United States. We'll see that in evidence in a number of different ways. And then, as I said, a seemingly unorganized collection of features, one of them just offshore British Columbia, Washington. You can see it there. We'll get a better angle in a minute. And then some precipitation in the radar that we'll see later on, just to the east of San Francisco Bay, and that's tied to a plume, perhaps tied to a plume that's coming from the subtropical eastern Pacific, not really deep tropical eastern Pacific. Okay, so let's take a look, Pete, if we could, at the West Coast satellite image next. And we have to use the infrared at this time of day, otherwise we don't get too much to look at. So I think you'll agree, if you've seen a lot of these maps, a lot of these movies over the years, this one just looks kind of like it was painted by a first grader who doesn't know anything about the way that weather organizes over the Pacific Basin. This is one of the swirlies that's kind of moving to the northwest of Vancouver Island. There's another smaller scale, a similar scale I should say, here in the central Gulf of Alaska. Bigger scale disturbances are about at the date line with colder air, and as you can see in the open cellular convection there, and a couple of little small swirls on the front edge of that. So what I try to do when I look at a map like this is I try to imagine what would the 500 millibar map look like in that region, just so I can kind of test myself. And so my guess is we're going to have a kind of a broad trough that's not really of large wavelength, a couple of little short waves embedded within it, not much going on south of that, so that it won't be very strong anticyclonic flow either, but maybe slightly anticyclonic, and then something that's kind of cyclonic to the southwest of the Hawaiian Islands. And so maybe we'll take a look at that. And along the coast, there's just broad southerly flow going across northern Mexico into the intermountain west of the United States. So no strong jet across the Pacific that makes its way, to about the Hawaiian Islands. No obvious strong development region, and so a somewhat boring early February map for today. Okay, can we take a look, Pete, at the National Radar Summary? And so, as I think I mentioned earlier, the cloud streak that's off the coast now had visited coastal locations earlier, and probably some further inland at a time even earlier than this morning, maybe late last night. And you can imagine some of these cells that have a speckle of red or orange in them are convective. And so maybe Columbia, maybe Charleston had a thunder shower this morning. We'll see when we look at the surface odds what sort of situation temperature-wise. I'm going to guess mid-50s or something, maybe even more, I guess. And so somewhat rainy morning, now moving offshore of the Carolinas and Georgia. So maybe the islands off the coast still have a few showers here and there. And then some light rain across central Florida, but if it does anybody any damage, the governor won't let you learn about it, so don't worry about it. So, and then some precipitation coming into the Puget Sound area. It's actually confined more maybe to the Olympic Peninsula. Right at the tip, you can see some pretty heavy reflectivity right there at the tip of the Olympic Peninsula, and that kind of gets eroded a little bit as it makes its way across the higher terrain there. And then here's the precipitation that I mentioned without having any proof that it was there. I'd seen it before to the east of San Francisco Bay in the central part of the valley. But boy, you look at this map across the whole country, even in the regions of cold advection across some of the lakes, you don't see any really strong evidence of lake effect bands, maybe one here just to the south of the Tug Hill Plateau, but in a little bit there near Houghton. But that's about all. Otherwise, pretty wide open across the country. So decent day for air travel, decent day for driving around if you don't like to drive when it's precipitating. Okay, can we go to the 500 millibar map, Pete, over the continental U.S.? And look at that map, isn't it beautiful? So, look at this, minus 52 degrees in northern Quebec at 500 millibars. That is the coldest we've seen this year. And so I thought we weren't going to see anything colder than minus 50. This should get some press in the Albany map list. I'll bet you that's about as cold as that station has ever seen at this level. So that's really desperately cold. And it's right on schedule. This is when if it's going to happen, this is when it's going to happen. But look at this broad, large-scale trough that occupies the entire eastern half of North America and then all the way to the longitude of Greenland, really, when you think about it, because the next trough is off the coast of Greenland. So this thing goes all the way to the Labrador Sea, and it's brutally cold over Quebec and Ontario. Temperatures in both of the provinces in the minus 40s everywhere. There's not a single station that violates that. It's minus 38 at Caribou, so it's not Quebec. So every place that's in Quebec or Ontario is minus 40 or colder. Just incredible, just incredible. And strong northwesterly flow over us ensures the continuation of clear skies. We have a beautiful clear sky day. One imagines a giant anticyclone sitting right about in this location, strongly forced by straight flow from the north and a tendency to propagate to the south and east. So that's going to make it still the air overnight in Pennsylvania, parts of New York State, in New England, really let that cold air settle in. And I don't know if they have snow in enough locations where in southern New England, but in northern New England they do. There's going to be a lot of radiational cooling. Temperatures will get down to minus 30 in some of those places, for sure, tonight. And then, though it's a somewhat oblique look at this part of the globe, one can see a broad-scale trough that goes all the way from the California coast to maybe the dateline, with a couple of little embedded shortwaves, and that accounts for this sort of wacky look to the satellite picture. As I suspected, here's the one that looked the best, the one that was just offshore of the Puget Sound. There's another one here, I think we mentioned, yeah, in the central Gulf of Alaska, and then a couple of other features. And everywhere south of this strong geopotential height gradient, the flow was cloudless, as we saw in the satellite. And that's broadly subtropical anticyclonic, I suppose, is the way one might describe it. So I'm always excited when I see the flow at 500 millibars coming all the way from the northern archipelago, unimpeded to Detroit. That's exciting. Doesn't happen very often, but when it happens at this time of year. So one of the things that's of interest is just how low is the tropopause in the middle of this exceptionally cold air. So before we go down, let's go to 300 millibars. And this is not the way one finds the tropopause, but if you see a bit of a thermal ridge, you can kind of get an idea that, and that's what we're seeing here. These are isotherms kind of going up into this geopotential height trough. That's a structure that maybe suggests you're sort of right at the boundary between the tropopause and the stratosphere. And you're 170 knots off the coast of New Jersey at 300 millibars, and 135 in the northwesterly flow that's ensuring continuation of anticyclonic conditions for us. So it's, and here's a good example. We talked a lot in 452 and 751 this fall about jet stream circulations. This one's just about straight, and it's stubby. There's a substantial amount of speed variation at the exit region of the jet. So one might expect there'll be upper divergence in this location, upper convergence in this location, associated with the speed change. However, you must add to it the upper level convergence that occurs because of the direction change. And so when you put them together, there's probably not strong subsidence here, but there's absolutely no way that you're gonna have strong ascent either. It's kind of a tug of war. And you could potentially partition the two and see which one's winning, but I think right over us, the cloudless sky from this morning suggested that for a period of time, this was clearly a weakly subsident region. This is now several hours old, so it's all moved a little bit further to the east, so we might actually have a change in the rules of the game. And I think the sky is clouding up a little bit, perhaps in response to that. Let's go to 200 millibars, Pete, just to see if we can see separate jet streaks. Yeah, the one that's to our north and west is very definitely a polar jet. It disappears at 200 millibars. It was 40 knots faster over Lake Winnipeg at 300. And then this one here is also weaker at 200 millibars, although not completely absent. So this would be more interesting to try and see what does it look like in a vertical cross-section, I suppose, than that one. That's pretty clear what the answer would be. Can we go to 850 millibars now, Pete? So at 850, how cold are we? Look at this. Minus 38 at James Bay, minus 38 near Montreal, and there's a minus 40 contour analyzed here. Kind of not such a good analysis for James Bay, but the analysis guess of the coldest air is minus 42.6 at 850. That's brutal. I don't know how many times you get below minus 40 at 850 millibars. I think it's a handful of times in the 30 years that I've been. So that's really exceptional. Here's the circulation center that we saw evident in the satellite picture over in Newfoundland, and a very strong low-level temperature contrast associated with it. Not surprisingly, when the flow is coming offshore, like it is here at Portland, it's coming offshore from the west, northwest, and we saw all those cloud streets. As this cold air spills across, you don't want to go swimming in the North Atlantic at this time of year, but it's still a lot warmer than minus 15. So that's exceptional cold advection across relatively warm water. And then the same was true off of Islip at Long Island. So very intense low-level baroclinic zone. Another real if the northerly flow is right over us, it warms right back up. Okay, can we, I think the last thing I want to look at, well, let's go to 700 feet if we could. Thank you so much for tending all of these various digital animals.
Something happened with the camera. We're going 700?
Yeah, 700. Just because the air is so exceptionally cold, it's fun to see what's going on. Look at this, James Bay at 700 millibars is minus 46. And the height there is, I can't read the number, so this is 2580. So let's just say it's 2580 meters above sea level. I think it was, can we go back to 850 again, Pete? And at 850, it was 1279. So what is that, 1200 meters? And the temperature is, can we go back to 700? I can't remember anything. 1200 meters, I gotta keep that in my mind, 1200 meters. And a temperature of 8 degrees. So we got a lapse rate in the middle troposphere, and the depth of this cold air is like 7 degrees per kilometer. That's colder than, that's steeper than the average lapse rate. So it's not so well stratified air in the middle troposphere. It's not unstable. It's not even really close to it. But nonetheless, kind of interesting. And that minus 46 is an odd. And the guess here is minus 46.5 in the analysis. And then here's the 700 millibar position of that baroclinic zone. As you can see, it's a little bit further to the north and east than it was at 850, and that reflects the fact that it slopes upward to the north and east. And so you're intercepting it at a further northern and further eastern location the higher up you go. but we didn't see it hardly at all at 500, so it's contained mostly below 500 millibars. And then the flow at 700 millibars does not really particularly strongly cut across it from warm to cold. That's more what's going on in the lower part of the troposphere, in the immediately of the Rockies. But at every single level we've looked at, this Hudson Bay low is the dominant feature, and it's the climatological feature at this time of year, and so this is a really nice example of that. Minus 46 at, minus 49 at 700 millibars. So Pete, what I'd like to do is skip ahead, sorry Patrick, I'm gonna go one time ahead. Can we look at the 0Z forecast from tropical, or whatever one gives us cross-section ability, I forget.
Maybe that's trouble.
And let's skip ahead to 0Z or 06Z at 500. Yeah, look at those thicknesses. Okay, right here is probably pretty good. Now let's take a cross-section right through there. This will be valid at midnight tonight. So from southern Hudson Bay maybe to about here, a little bit north of Bermuda. Yeah, perfect. Let's just see what the PV looks like. That's remarkable. Okay, so remember, B is out over the ocean. This is 2 PVU that's shaded. So that's stratospheric air. Now, we don't have the ozone mixing ratio on this, but they are going to be close to hand in hand, right? If you have high tropopause PV, you probably have pretty high ozone mixing ratio relative to the average. And then look at the oceanic boundary layer. It's perfectly neutral. So, and you can see it starts right there. And so, if it's true, and I don't know that it's true, but if it's true that this air in the middle, in the heart of that really desperate cold air mass, is moved the stratosphere down, it's gotten down all the way to about 700 millibars in some of these places. And that 700 millibar stratosphere is sitting on top of a well-mixed oceanic boundary layer. So if you can kick something up, somebody mentioned, maybe it was Patrick or somebody else, there may be a whiff of ozone on sailing ships just offshore of New England tomorrow morning or at midnight. Anybody who's foolish enough to be in the sea smoke at that time of day under these conditions maybe would deserve to have a little whiff of ozone. Well, I don't mean it in a bad way. That's ozone hunting. You're trying to look for the lowest tropopause you've ever experienced. This is probably it. So just incredible what's going on there. And as I said, that's in the heart of the thickness minimum. So one gathers that it's kind of in the heart of the coldest air. So a remarkable cold pool that's going to flow off the coast of New England. It's going to be a brutal night tonight. One of the cool things in the forecast that I saw is that the cold pool at 850 evaporates away. And so why and how is a subject for further inquiry. So that's all I have for the discussion part today. Any other questions or comments? Ian?
I was wondering how you handle having like near zero stratification immediately beneath a feature that we would apply like the QG omega equation or Soyer-Elysian to, something like that, where...
Well, you can still apply those relationships here, especially the QG omega equation, because what you often do there is you assume a constant static stability, which is not zero, like it effectively is here. The moist static stability here is zero. The Soyer-Elysian equation is a little different because you have less control. You know, the elliptical condition comes out of the coefficients, and those coefficients have an actual value in your domain. So you don't have overt control over that. But what you could do is you could say, if you were trying to solve for a frontal circulation in this environment and you found places where the stability went down to zero or just close to it or just below it, you can just put grid point values in that are slightly above it to ensure that you don't meet that ellipticity, or that you meet the ellipticity condition and get a solution, but that's cheating. You don't have to cheat with the omega equation in such a clandestine way. You just overtly say sigma is 2 times 10 to the minus 5 or something.
Sweet, thank you.
Neither of those answers tells you anything about what the atmosphere is really doing at that boundary, which is cool, because there's updrafts. There's bound to be updrafts in here, and they're going to mix this air because they don't have any restriction against it. And that's very interesting. Potion.
Not to distract from the main feature here, but with the wonky Northern Pacific, do you think it's the start of like the midwinter suppression season?
Well, that's a February phenomena, yeah. As far as I understand that, which is poor, The jet gets so strong in February, because that's when you get coldest, that the whole thing gets more zonal. And as a consequence, little disturbances that might seed the jet in Siberia and places upstream just get stretched out of existence in terms of being potent cyclogenetic entities. So that could be part of what's going on. Yes, it's quite possible that's the case. I wonder if, you know, if you took a bunch of images at 6-hour intervals of the Pacific infrared satellite image, threw them at some sort of a sorting program like a self-organizing maps thing, could it tell by how dilapidated the structures looked what month it was? That'd be a really good blind test. And if it lined up that, wow, all these dilapidated ones fall into a bin and almost all of them are in February, you'd really have a good starting point to make that case.
A lot of sims found it in February, so.
A lot of what?
The simulations, they mostly found it in February.
Yeah. Nakamura's original work on that shows that that's the time that it happens. So it's quite interesting.
Were you gonna show something for the weather service?
Oh,
You
yeah,
mentioned that first kind of-
let's go to the weather, thanks Pete. See if it's still up there. We'll go to the Weather Service Milwaukee page. I brought this into class, I think on Monday or Wednesday, and I didn't show it. But we were getting close to the end of January, and January's unusually warm around town, around the state, I should say. Let's see if they still have that stuff up. That was pretty neat. And it was down below, I think. Yeah, Milwaukee climate, Madison climate for January 2023. So you can, let's see. I think they'll give us one page at a time. Okay, so, oh, there it was. Yeah, we click on that. Let's take this climate look. Okay, so for Madison last January, the lowest was the last day of the year, -11. So it wasn't as cold today as it was then. So -11. And this was the 8th warmest January of all time. The average high departed by 5 degrees. The average low was even worse. So the average daily temperature was higher by 7.6 degrees for the month of January. Boy, if we avoided this, who knows? We might have been in the top 5. And then we had 13.9 inches of snow. It's just about normal. Most of that was in that one day where we had the 7.3 on Saturday last week. Milwaukee, 4th warmest ever. And they were only -3 on that same day, and as you can see, their average was about 8 degrees above average. And that's enough to get 4th warmest in Milwaukee. It's only enough to get, a similar departure is only enough to get 8th warmest in Madison. And then Milwaukee also had its biggest event on the Saturday, just about exactly the same amount of snow, and almost the same monthly total. But they usually get a little bit more, so they were a little below the average. And we were not, in either city, in the top 10 driest or wettest. So it wasn't really a precipitation anomalous winter month, but it was definitely a temperature anomalous winter month. And so who knows what's in store for February, except that, as we were talking about, February, 2 weeks from now, you can't make cold air anymore at the high latitude. So it's over, the factory shuts down. And so this might be the last one that we have to contend with. And let's just see whether or not that turns out to be right. And those are conditions, you know, you can't negotiate those conditions. The sun's coming up at all those latitudes, it's over. So we've had a really mild winter. It's really been nothing to speak of. Okay.
Graphically, that's.
Oh, and Pete's, Ed's got these updated now, so you can kind of see the daily temperature range and where it sits compared to the daily average high and the daily average low. So there's our cold spell. And even with this remarkable depression in the time series, we were still the 8th warmest Madison January ever. It's pretty unbelievable. So next week I'll bring the 850 cold pool for January too. It would have been a nice follow-up today, but I don't have it. And we're kind of just about average for snow. Although
It's actually liquid precip.
Okay, so that's a good point. I was just going to say, it seems to me they're talking about us being a little bit above average, which I really don't buy. I mean, let's put it this way.
Doesn't feel like it.
Snow excitement, we're way below average. Okay, so I don't know what they do out there with their snowboard, and they brush it off every 5 minutes and measure, you know, the depth of 8 flakes or something, and they get these exaggerated totals. Snow excitement has been well below normal this winter. We haven't even really had a chance to talk about an event. In fact, the one last Saturday surprised everybody. So, in terms of the second round of it that afternoon. Okay, thanks for your attention. Patrick.
Perfect, thank you. Could we go to the surface map first?
Our surface map?
Yes, the current surface map. So I'm going to talk about mostly the cyclone that's sitting over Newfoundland currently. So if we could zoom in all the way up eastern Canada. Let's see, so here's the cyclonic circulation associated with that cyclone. 979.9 looks like the lowest pressure reading, and so I wanted to look at where is this cyclone going to move and how is it going to influence the cold temperatures that are currently sitting over Canada are going to shift into the northeast United States. So let's go to this tab, the 12 UTC GFS model. So this is the GFS model run for the northern hemisphere, and let's go to 0 hours first on the surface. So this is a look at this morning from the GFS. That pressure is 980 something, I can't really read, but it has almost the exact location of the cyclone based on where the odds were at the current time, and you can see very low thicknesses situated right to its west, and those are all being convected over the northeast United States. And so let's track this cyclone and see where it moves. So if we could go
That's a 984 contour.
984,
I'm not
yeah.
sure what the lowest value is.
Can't be lower than 980.
It's 988 and the one outside
Yeah.
of it.
It's unfortunately placed by the computer.
Yeah.
But let's go ahead 6 hours from this look. So this is a look at noon. Now we are at 975, so that's the guess from the GFS, which is a little lower than what is being observed, but the location is about the same. So let's go ahead another 6 hours. We're at 975.
6 hours?
Yeah, 12 hours. Now we're at 970, and then let's go ahead another 6 hours. This will be the interesting. So now we're at 18 hours in the future. Now we're at 955.
Whoa.
So that's a jump of 15 millibars in 6 hours. And this is while all of that cold air is getting funneled right into the Northeast Pacific Ocean, northeastern United States, excuse me. And if we go another 6 hours for completeness, this will be a look at 6 a.m. tomorrow. I'm not quite sure where the reading is. It was below 950. So it got, when I looked at this earlier, it was down to like 947.
Yeah, that's in the high 940s because you can see where the 976 is.
Right.
Wow.
So that is a significant cyclone that is sitting over Newfoundland with a very cold Arctic air mass situated right near it. So let's take a look at why this deepened so significantly, especially that 6 hour period. So let's go to 500 hectopascal, the same look. We'll start at 0Z, we'll just go through the same progression. Here's the trough we were looking at earlier. This is from this morning. So it's not the same time as the current, but here's the trough and extending all the way across most of eastern Canada. And you can see a little downstream ridge beginning to form associated with the cyclone and its development. So let's go 6 hours ahead now. We can notice now there a lot of the vorticity, which is in the shading. I should have explained that. This is a look at 500 hectopascal. Absolute vorticity in the shading, the contours are heights. So you can look at where there is vorticity, absolute vorticity, and where it lines up with the troughs and ridges. So at this time now, we have a maximum vorticity right in the center of that trough, and you can see there's high values of absolute vorticity right near 0 or slightly negative values of absolute vorticity. So there's a strong gradient in vorticity right over where our cyclone was located at this time, based on the GFS model run. So at the same time, I'll put my pointer right where that gradient is the strongest. Let's look at the surface again. So this is 18 hours, or 18 UTC.
Oh, yeah, that's right.
Yeah, that's right. So you can notice that I'm looking at the thickness lines, the dashed contours. That will tell us where there is positive vorticity advection by the thermal wind. And anyone in 452 or 751 knows that that forces rising motion. And so we have thermal wind blowing almost perpendicular to where that gradient is located. And so that is going to be very strong positive vorticity advection by the thermal wind right where we would expect this cyclone to potentially move based on the thickness. And so if we track that, I'll put my pointer back where it was. If we go 6 hours in the future from this current time, let's go to the surface, please. Lines up almost exactly where you would expect based on positive vorticity advection by the thermal wind. And you can notice there was a decrease in the central pressure. So it is strengthening. There's massive actuation in the column. leading to rise in motion in ascent and mass evacuation. And so if we do the same analysis now for the next 6 hours, so we'll go the same look, so we were at 12, or hour 12, we'll go to
12.
Yes, please. We'll go to 500 hectopascal. So we still have that strong vorticity gradient, nearly coincident with where the surface cyclone is. It's not as pronounced at this time, but there still is a vorticity gradient. I'll put my pointer, let's see, maybe somewhere in the middle of where this gradient might be the strongest. We'll go back to the surface at the same time. And we noticed, yet again, the thermal wind is blowing from high values to low values. So that's still strong advection of positive vorticity by the thermal wind. And if we go, I'll keep my pointer right where this is located. If we go ahead from this look, another 6 hours, so 18 hours in the forecast, matches up pretty nice with where the cyclone moves. And this is that rapid deepening period where it's now 955 hectopascal. So a significant development and significant strengthening of this storm, and at the same time, we have the Arctic air. It has been dislodged from the Arctic heading over the northeast United States. So let's go to 850 at the same time.
And one other thing, Patrick, this is really nice
Yeah.
analysis. On that last picture, one thing that's true also about this development environment is that it's moved off of Labrador. So it's out
That's
over
right.
the Labrador Sea, and that makes a big difference because the static stability is really low.
That's right.
You know, as we were talking about earlier. So in the real world, that you cash that in for stronger vertical motions and stronger mass evacuation, as you're pointing out. It's strongly forced, but the stability is reduced almost to zero, and suddenly you just explode it over the surface. And there's no warm front.
Yep. That's right. You're moving air from literally from the Arctic over the Atlantic Ocean, right where you have synoptic scale forcing. You're going to produce a 955 hectopascal cyclone. That's almost a given. But at the same time, let's go to 850 hectopascal. So this is 6 UTC.
Whoa.
This is, so look at midnight tonight local time. You can see the coldest air in all of this map is located nearly over Maine and New Hampshire. And if we remember the surface pressure, this had very strong gradient in isobars, which results in a strong gradient in wind at the same time. So Arctic air, you have a very deep cyclone to your north, that's going to advect strongly cold air towards your region and result in wind chills that might even set some records in this part of the country. And so let's take a look at that now. If we could go to the next tab I had, please.
Could we go back to that one chart? Just,
Oh yeah.
I don't mean to intercept
No, that's
your
fine.
discussion, but also, we had this cold snap this morning, and look at what's setting up for us.
Yep.
This warm bubble in the lee of the high terrain on the western periphery of the cold air. We have strong warm advection that's invading by
right.
midnight tonight, so we're going to warm up fast.
And that's why it's going to be 35 tomorrow or
Yeah.
something ridiculous like that. When it's -2 right now, it's pretty incredible. Okay, so let's go to Caribou, Maine now. This is National Weather Service of Caribou, Maine. Wind chill warnings for obvious reasons. But let's scroll down. They have a graphic here. If we could open this. And it doesn't get any bigger than this. I tried to blow it up, but I'll read out these numbers. So -55 in Caribou wind chill, -62 in Clayton Lake. There's a mountain here, not sure how to pronounce
Oh,
it.
Mount Katahdin. First
Minus-
place where the sun hits the United States every day.
-80 degrees Fahrenheit.
Patrick,
Yeah.
did you say this is at the surface?
Yeah, these are places where people live. Yeah. Maybe not anymore. Maybe time to go. But so there's a chance that some of these wind chills will be the coldest that have ever been observed at some of these stations. And we can look at that. I found a website, and I'm sure a lot of people know about it if we go to the next tab.
Do we know if there's an ozone station on top of Mount Washington?
There is, I think.
Is there?
From what I heard, yeah.
That'll be interesting.
It will be. So this is, if you're not familiar with this is the Iowa State Mesonet, the Iowa Environmental Mesonet. They have a website where you can plot data from any ASOS station very quickly. So you can look at records, which I had never seen this before, like, I don't know, 2 weeks ago. So we want to, it's pretty easy to use. If we click that drop-down menu, you can see you can pull up accumulated precip, If we keep scrolling, daily maximum dew point, I mean, there's a ton of things you can pull up. So if we search wind chill on that, please, Pete, we can look at, here we go, the minimum wind chill at any ASOS station for the whole period of record that they have. If we do select plot type, and then we can select our station. So first we'll go to Maine. And if you can see, there's Hungary, there's Kazakhstan, there's,
Wow.
I mean,
That's awesome.
you could spend a whole year looking at this stuff. Go to Maine, middle up. There we go. And first we'll look at caribou. So then we find caribou, and we'll limit our plot and only plot winter. And if we do make plot with options. So right now it's plotting all of the minimum wind chills that have ever been observed in Caribou, Maine for the whole period. And could we blow this up by chance? Is there a way to zoom in? Perfect. So we were looking at -55 in Caribou, Maine, forecast. If you notice, this is a time graph of the minimum wind chill per year, so the whole record. -55 has only been observed twice.
Wow.
And that was in the 1950s. It has not gotten below -50, maybe even -45 for a while. And so if that verifies, this could rival some of the coldest wind chills ever observed in Caribou, Maine.
Wow.
And what's even more exciting, if you go to, now if we scroll up, we can quickly, let's go to Clayton Lake, that other, so they were forecast to get to, and we could just do make plot with options. -62 Fahrenheit. I'm gonna wait here.
Oh my God.
That's only, below -60 has only been observed 1 year in this whole period.
Below -50's only been observed once.
That's right.
Wow.
So this it might very well set the record for the minimum wind chill ever observed at some of these stations, which is pretty remarkable. And then if we go for fun, we'll go to,
Wow. And unsurprisingly, nothing happened in 2008 at this station in Maine.
right, we'll do one more of these, which I find fascinating. We'll go to New Hampshire and look at Mount Washington.
Oh, yeah, that's a great place to look at stuff. Further down.
Keep going.
There you go.
And then luckily there is a station on the top of Mount Washington here. And we'll do the exact same plot.
UW-AOS.
Hall of Fame one right now.
And then we'll scroll down.
Pretty amazing site.
So this is the,
Wow. Wow.
this is the windiest place that is regularly observed on the globe. You can see they get down to -100, they have before. Current forecast is -99 for their minimum wind chill. Temperature of -47 Fahrenheit with winds up to 130 miles an hour.
Wow.
So, -99 could break the record at Mount Washington as well.
Wow.
So just unbelievable cold in some of these locations.
Unreal. That's awesome.
Open the door if you observe.
Yeah.
I don't know if you can open the door, it's probably frozen shut. Okay, and then I have a quick, I'll just look at the forecast for our area quickly. We could go back to the UW-AOS, the GFS model runs, if that's still up. Oh yeah, perfect. And we'll just look at the surface. So we'll start, let's go to,
Just bring up the loop and then we'll just.
oh yeah,
pause it.
perfect. So this is a look at the surface. Guess for this morning, we had high pressure over us, very cold thickness. If we step ahead 24 hours now,
Pressure 1040, Jesus.
so now this is, tomorrow morning at 6Z, we're kind of in between a low and high pressure, but that means that flow would be out of the southwest, which would advect some of this warm air, these warmer thicknesses over our region, and we'll most definitely get above freezing tomorrow. This is a look at 6 a.m. and we're almost out of the 540 line, so
Yeah.
that's pretty strong warm advection, pretty significant change in our temperatures. We keep going another 24 hours. So this is a look at Sunday morning. We're kind of maybe slightly cold advection based on the flow around this low pressure, but still 540 line is around our region. We'll probably have about the same temperatures as Saturday, and then we'll go another day here. So this is a look at Monday morning. Again, we're in, let's see, where are we? We're in a region where we have kind of in between a high and a low, but potential for strong warm advection to our west, which might eventually move over us and we'd be in a warm air advection regime. So we might even get in the 40s next week, which will feel tropical compared to our current temperatures. And then the last thing I want to show, if we could go back to just the look at the, we just go back like one click. We'll go to 100 hectopascal. And let's go to 36 hours. So if you didn't know, there's a spy balloon over Montana right now. And it's sitting about 100 hectopascal. There's a chance that if this balloon follows 100 hectopascal, that it might end up somewhere in our region. If it's not shot down. But something to watch. So we might have to take a field trip and go watch a spy balloon over our region. But that's all I have.
Awesome.
All right.
Thanks very much. That's great. Thanks, Patrick.
Yeah, thanks.
It's sort of disconcerting if you're in the Chinese intelligence service